Hey guys, so this is pretty much how I'm gonna be doing the lessons for new concepts, new topics. So these are pre-recorded. If you're watching this, you're on YouTube right now. So make sure you subscribe. Okay, I don't care if you like or if you comment. I mean, you can if you want to. The most important thing for you to do is subscribe so that I don't have to keep sending out these super annoying emails saying that I uploaded the video for the week. So there is actually, I already said it, there's going to be one video a week. One pre-recorded video a week. Pre-recorded. And so, pretty much, like, these pre-recorded videos, I'm going to be teaching. I'm going to be answering the questions that I think you will ask. And so that, if you still have questions, then you would attend the live review sessions held twice a week. Okay, so the live review sessions, that's just like a Q&A session. Okay, you do not have to attend. Do not have to attend the live, really they're review lessons. If you feel like rewatching this video over and over again is good enough, then perfect. You do not have to attend the live lessons. One more time, the live lessons held twice a week at the same time are only for Q&A. Okay, so this video that you're watching right now is mainly for pausing, note-taking, rewatching, right? So that's actually the plus when it comes to videos that you watch. You can always stop me, like, if we're, like, face-to-face in the classroom. But if you just need to hear something one more time or two more times, that's actually a huge benefit to online. Okay, so I'm gonna actually, where do I want you? I want you here. I'll put you here. Okay, so without further ado, let's go ahead and move on to the next. Oh, see, there it is. The next slide. Okay, so, this is, I know it says the date, but the date is wrong. We're still in week 2. Okay, still week 2. Algebraic Foundations. You should title, this should be your title, Algebraic Foundations. You should know, oopsie, undo, oh my god, sorry. You should know PEMDAS. Go ahead and write this down. This should be ingrained in your memory at this point. So also known, aka order of operations. I'm just breezing through this because we did discuss this in the live lesson last week before that hurricane scare. So, order of operations, it just tells you in what order to do everything. These kind of come in clumps. This kind of goes in a clump. So parentheses, exponents, multiply, divide, add, subtract. It's pretty self-explanatory. This was due last week, if I'm not mistaken. So if you have questions about this topic, then please do not hesitate to ask in the live lesson held later on during this week. Okay, so bring your questions about this topic to the live lesson. Okay. Distributive property. This is what I wanted to start talking about. So, I want you to write everything down. Everything that you see, I want you to write it down. Okay. So, literally, it just allows, so the distributive property, very important property. It allows us to get rid of parentheses by bringing a multiplication from outside to inside. I would rather look at this, or this, or this, as opposed to that, or that. Here's a key. Always make life easy. Get rid of those parentheses. Get rid of the parentheses. So guys, as I'm writing, you should also be writing. That's just a key. Okay, so the distributive property allows us to do that. Allows us to get rid of parentheses by bringing the multiplication. So distribute, actually, it literally just means like pass out, and you can see actually that you're like just passing out that number, right? And it is multiplying every single time. You're going to be multiplying. So here, an x times an x gives you an x squared. And, I mean, it's pretty self-explanatory. Again, if you have questions about this property, I want you to bring them to the live lesson. Okay, because I do think that we went over it last week. Okay, this I want you guys to write down. Just pause the video and just write it down. I mean, it's great to know. You should know these by heart. Okay, 1 through 12, you need to know by heart. This one, they become a little easier to remember, like, the more that you look at them. This one you should know. Honestly, just write them all down. It's good to know them. So just pause the video for a second and write them down. If you want to know, so obviously you should also know square root of 100 is equal to 10. Square root of 400 is equal to 20. So square roots are the other half. Square roots. So you should know square roots as well as perfect squares. Okay, so because they are inverses. Inverses. Actually, I do not want that there. I don't know what the hell I was thinking. Let's, okay, let me write that again. Exponent 2, so squared. Squared. And square root are inverses. Okay, very important. Very, very important. So guys, if I'm taking the time to write something, then you should also be writing it. Make sure you have this. I would just dedicate a whole page to this, honestly, or a whole half page. You could, if you want, you could do like half perfect squares and then half square roots, just so you can fully understand the inverse relationship that they have. Okay. So I want to go ahead and talk about, so this should be a whole new section in your notebook, solving for unknown variables. Okay, this topic, super, super critical. Okay, so we were supposed to go over this. No, we're right on track. So, I want to go ahead and, I hate how I did that. I hate how, I'm sorry, guys. Okay, so the whole idea with solving for unknown variable, big idea. Isolate the unknown. The idea is to isolate the unknown, okay? And the way we isolate the unknown, the way we do that is by utilizing inverse operations. Okay, and so I'm going to list them all, actually. So add and subtract. Those are inverses. You know the next one. Multiply, divide. Inverses. Okay, one more. I'm sorry, one or two more. Let me undo that, actually. Exponents. And then their roots. So when I say roots, so say if my exponent is a 2, right? Then this tiny invisible 2 with whatever number. So this is the base, that's whatever number. Also, no, I don't want that. Also, let me move this. Okay, so say if I have 4 to the 3rd power, okay, then the cube root, I would need the, oh my god, I would need the cube root, right? If I have 6 to the 5th power, okay, the exponent is 5, then I would need the 5th root, okay? So this 2 right here, which honestly you never really see it. It's actually an invisible 2. So every time you see, you've always seen the square root, but this tiny 2 has always been there. It's just been invisible. But when you start getting into cube root and then the 5th root and then all those numbers, they become visible. Okay, so back to inverse operations. I'm going to erase this. So if you want to write it down, which you should be writing it down. No, I want the whole thing. Yeah. Okay. Oops. All right, so we have 1, 2, 3 exponents, roots. Yeah, those are all the ones we're going to talk about now. And so when I say inverse operations, inverse just means, here's a definition for you. Inverse just means undoing each other. They're undoing each other. Okay, so they're opposites. In other words, they are opposites, aka opposites. Another way to think about it, 3 times 1/3 is going to give me 1. And the reason that works is because 3 over 3, right? So, I wish I could switch those, but, okay. So, this is multiplying, this is dividing. So, 3 multiplied by 1 divided by 3. So, multiplying and dividing are inverses. And so, when you have inverse operations, you are going to get 1. You should get 1. That's actually one of like the main ways to tell if you are using inverse operations. With multiplying and dividing. With adding and subtracting, it's 0. Addition and subtraction undo each other. So say if you have 3, well, not 3. No. Sorry, guys, I'm learning still. Say you have, say you have 4 minus 4, right? Well, that's really positive 4 minus 4. So positive 4 minus 4 gives me 0. And so positive and negative are inverses. They're opposites. They cancel each other out. That gives you 0. So that's just a very, very like short example of how inverses kind of work when they're side by side, when they're both involved in the same problem. And so like I said earlier, the way to isolate the unknown is by utilizing inverse operations. Very, very important. And you've been doing this all the time, you know. So I want you guys to write this down. The beating heart of mathematics. So mathematicians use logic to determine the unknown and uncover patterns of the universe. Okay, so there's a lot in the universe that we do not know. There's like a huge amount of information that we don't know. We don't know what we don't know. And then we know what we don't know. So there's a huge mass of knowledge out there that's waiting to be figured out, that's waiting to be understood. And the way we determine the unknown, well, first we have to figure out what we don't know, right? And we determine the unknown by isolating unknown. So just like in chemistry, right? So if they want to learn more about, say, a new element, right? An element. I really don't know that much about chemistry. It's actually like my weakest subject. But so like pretty much what they'll do is just so that they can like they will literally put it in a machine, right? And they will literally tear apart the element or the atom or the what's the word where it's like hydrogen and like oxygen. I think like a compound. I really don't know, but they'll put it in like a machine, right? And then they will literally like tear it apart. They want to understand it, right? And they use all this force to tear apart these molecules. So they tear apart these molecules they literally are isolating the unknown, right? And so they study it, and then they tear it apart some more, and and these machines cost millions of dollars, billions of dollars. And this is how they come up with new elements, with new molecules, with new building blocks of like the material universe. This is how they figured out like what the chemicals that human beings are made of, right? Have you guys ever heard that human beings are made up of the same like chemicals and energy and molecules as like from the Big Bang? I don't know if you guys have ever heard of that, but it's true. So like the stardust, literally stardust. Okay, we're literally made up of stardust from the Big Bang. Okay, like that. I think that's so cool to me. And they found this out because they tore apart molecules and elements and isotopes and whatever, all those fancy words. They tore apart these building blocks, these little things that form in the sun, that form, when a sun explodes. And they studied them. And so they couldn't do it without math. And so I just think that mathematicians are, honestly, they're like the coolest thing. I mean, they can be super annoying, but in my opinion, they're pretty cool too. So please think about this topic. Mathematicians using logic to determine the unknown and uncover patterns of the universe. Okay, so moving on. Okay. Very went over that. You guys know this. You should know this. So pause this. Pause here. If you want to write this down. If you haven't written it down yet, go ahead and write this down. So I'm going to move on. Pause also here. Also very important. I just finished talking about that. So addition and subtraction, multiplication and division are opposites. Addition and subtraction are opposites. And squaring and taking the square root, those are also opposites. Okay, so guys, I think that's it. I don't want to jump too far ahead. We're still in week 2/3. So, let me add a new slide, actually. Can I add a new slide? Yeah, yay! Okay, so let's just do a couple of examples. Solving for x. Solving for unknown. variable. Sorry about my handwriting. Oh my god. Let me find a file. I'm sure I have a lot in here, actually. Let's try here. I can go over FOIL also. You know what? Let's actually do, let's do some, let's actually do some distributive property first. Let's see what happens. Wait, what happened? What just happened? Sorry guys, hold on a second. Oh, here it is. Oh, okay, here we go. Actually, let's go ahead and do distributive property first. I'm going to do 3 examples. Okay, so here we go. Actually, I don't want to do those. Those are too easy. Well, I mean, they're all pretty much the same. Yeah. Let's do 1, 3, and 5. Notice it says simplify. Notice it says simplify. It does not say solve. Okay, so I want to stress that simplify, not solve. We are not solving. Okay, so as I'm writing, you should also be writing. These are great examples. Stop it. So here we go. I'm going to start writing, and I'm going to do it in red. Okay, so solving is when you find the answer, right? We are not solving here. We're just making life easy. We are making life easy. We are making things more simple to look at. I'm sorry about my handwriting. I'll get better, I promise. Okay, so solving and simplifying are not the same. Okay, so now let's begin. Erase that too. Let's do it in blue. Okay, so the distributive property literally tells us to distribute. Distribute. Root is distribute. So I'm going to draw the arrows. 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 So keep in mind, right, this is a positive 6. That's a positive 1. And that's a negative 5m. Okay, so positive 6 times positive 1 is 6. And then positive 6 times negative 5m is negative 30m. And there you go. And your answer is this. I mean, you can't do anything else because this is just a number. This is a number. And this is a number. And this is a variable, right? There's a letter attached. So you cannot combine anything with anything else. You are finished. It's like apples and oranges. You're done. Okay, so moving on to number 3. So I'm going to draw the arrows again. Okay, so now we're just going to multiply. Positive 3 times positive 4 is 12. Positive 3 times positive 3r, that is plus 9r. And there you go. And then last one, I'm going to move it. Make it as big as I can. I'll do 7 too, why not? I'm going to draw arrow again. Notice this plus sign always, every sign, you know, it's always attached to the number behind it. Okay. One more time. 4 times 8n, that is 32n. Positive 4 times positive 2 is positive 8. Okay. And then last one. Negative 6, so that's a positive 7, that's a positive 11. Okay, so draw the arrows. Negative 6 times positive 7, so that's negative 42k. Negative 6 times positive 11 is negative 66, so minus 66. Okay, so this was 4 examples on single distribution. Okay, if you have questions, you know what, let me just do a couple examples on double distribution. No, not that. That's solving for x. Let me find one more on FOIL. I saw FOIL. Oh, here it is. Okay, guys. So I'm just gonna do I'll do 2. I'll do 1 and 3. Okay, multiplying binomials. Find each product. Okay, also known as FOIL, which we talked about last week. Okay, so I'm just going to do a couple examples. So if you guys remember, first, the outside, inside, last. I'm going to color code. Actually, these are the first terms. The outside terms. These are the inside terms. And then the last terms. Okay, so let's go ahead and start. Okay. Let me actually... I'm gonna actually make this white. Just so I can make some room. Okay. Okay. So let's do the first terms. So that's 3n and n. So 3n times n is 3n squared. Okay, that's the first term. The outside terms, 3n times positive 3. So that is 9n, or positive 9n. The inside terms, positive 2 times positive n. Okay, that's just 2n. And then the last terms, positive 2 and positive 3. That is just positive 6. Okay, so now we're going to put them all in one line. And I want black. So that's 3n squared plus 9n plus 2n plus 6. The last step is going to be combining like terms. And so these are the only two terms that look the same. This is just a number, and this is a number with n squared attached to it. And so these two middle terms are the only two terms that have a single n. And so we're just going to combine them. And so your final answer is 3n squared plus 11n plus 6. Okay. Go ahead and that's your answer, guys. Go ahead and pause the video if you want. This is everything. Go ahead and pause it right here if you want. I'm about to move on. I'm going to do which one do I like? I'll do number 12. I like number 12. Okay, so I'm about to erase. Okay. Let's go ahead and do there we go. So one more time. F O I L. First term. Those are the first terms. The outside terms. Outside. These are the inside terms. And then these are the last terms. Okay, so now I'm going to make the color, I want it black. Okay. So the first terms, that's 5x times 5x. That is 25x squared. Very important. Okay. The O, outside. So that's 5x times negative 8. That is a negative 40x. The inside terms, negative 2 times 5x, negative 10x. The last terms, negative 2 times negative 8. That is actually positive 16. We're going to put them all together now. 25x squared minus 40x. Get out of the way, literally. Minus 10x plus 16. One more time, we're still gonna, it's a 40. We're still gonna combine the middle terms. Okay, so our final answer, 25x squared minus 50x plus 16. That is your final answer. Okay. So this is double distribution. Okay, go ahead and pause the video. That's the entire thing. Pause it here if you want to take a little bit to make sure you have your notes correct. I'm going to move on to solving linear equations. Okay, I'm going to just pick a couple. So let's go ahead and do... undo. I want something with on both sides. You know what? I'll do 21. I'll do 21. Nah. I'll do 20. I'll do 17. This is just practice. If you feel like this is too easy for you, then honestly, that's great. Okay. Honestly, let's start with 17. Okay. Okay. So first things first. So we're gonna throw in a little bit of PEMDAS. Okay. So PEMDAS tells us do the parentheses first, and we're gonna execute PEMDAS using distributive property. Okay, so all right. So we're going to distribute first, so that's 4 plus, that is 3x. And then 3 times positive 2 is positive 6 equals 10. Now we're going to combine like terms. And these are my like terms on the left-hand side, right? So that's 10 plus 3x equals 10. Now we're going to move, the x is our unknown, right? So we are going to, hold on, let me make more room. Literally work with me. Okay, so now remember the idea is to isolate the unknown, and we have to get it all by itself on one side of the equation. So I'm going to subtract 10 on both sides. So that gives me 0, and that actually also gives me 0. So 3x is equal to 0. Last step, we're going to divide by 3, because right now we're multiplying, and the inverse of multiplying is dividing. The opposite of multiplying is dividing. And so now we're going to get, on the right-hand side, we're going to get x equals 0 divided by 3 is 0. So x is 0. All right. And you can actually go ahead and plug that in. You can always plug it in to check your answer. So 4 plus 3, 0 plus 2. And so that's 4 plus 3 times 2. So that's 4 plus 6 equals 10. And we are correct. Okay, so now let's go ahead and erase. So pause it here. So your answer is 0. Literally just like erase it all. Where'd it go? Why is it doing that? Oh, okay, here we go. Wow, it really just did that. Okay, I'm just gonna erase. Okay, so let's actually go ahead and do, let's do number 13. Okay, let's do this one. 3x plus 2x plus 6 equals 15. And so remember, the goal is to isolate the unknown. And so first thing we're going to do, -6, -6. So that cancels, and that's left. That gives me -21. So now I've got 3x plus 2x equals -21. And now we're going to combine like terms on the left-hand side. Last thing, we're going to divide by 5. So that gives me 5 divided by 5 is 1. So that's x equals. And honestly, this is not, you can't simplify that. So I will just leave it negative. That would be my final answer. Alrighty. Okay, so I do want to stress the fact that there is no single way to solve for x. There are multiple paths to the right answer. The main goal, though, is making sure that you're using your opposite operations correctly, efficiently. You do want to utilize these three big concepts, right? You want to utilize combined like terms. You want to utilize your opposite operations. Okay. You want to utilize PEMDAS. You want to utilize distributive property. Okay, these 4 elements, these 4 skills, will always help you solve for the unknown variable. And so, guys, I think literally, how long has it been? I don't know how long it's been, but let's see if I can. So those were examples. So if you need more help with solving for x, please bring them. So you can literally, there's so many different, Brooke, like, this is like a gold mine for you. This is great. If you want, you can just like take your pick and practice. Please bring any questions you might have about solving for x, or PEMDAS, or the distributive property, or FOIL to the live lesson later on this week. And yeah, literally, like, I'm gonna end here. Okay, so thank you guys for watching. Thanks. Make sure to subscribe. Please do your homework, and I will see you guys next time. Okay, bye.